All right, so the premise behind the domain for radicals is you have to recognize that under a square root, this number has either got to be positive or it's got to be 0. The one thing you cannot do is let it ever be negative, so you can't let that happen. All right? So when we do that, here's what we're going to do. In order to solve this, you're going to set 5x plus 6 to be greater than or equal to 0. Now, the number one question that I hear people say is, what about the 3? The 3 is immaterial. Don't even worry about the 3. Okay? And again, I know that that's a scary thing for people to do, because then people go like this, well, hell, I ain't worried about the 5 either then. Hell, shit. I'll get rid of the 6 too. You know what? Heck with the whole damn problem. No, that's not an option. You can't do that. The 3 is not an issue for you because the 3 is not dealing with is the inside positive or is the inside 0. The 3 is on the outside. Okay? So, set 5x plus 6 greater than 0, subtract 6, 5x is greater or equal to negative 6. Divide by 5, and you'll get x is greater than or equal to negative 6/5. Interval notation, that would look like negative 6/5 to infinity. Put the bracket on the negative 6/5. Okay. That's the answer for that one. All right, so the question is, does the infinity always come second? And the answer to that is no. See, next example. The plus 7 here has no effect on the problem. So the plus 7 is basically immaterial. You can leave it alone. All you have to do is set the inside part greater than or equal to 0. Now, the problem that people will have, for people who are just trying to get by or just want to barely fail, what they'll typically do is go like this. They just set this equal to 0. They never do greater than, they just do equal to. They get the answer, they say x equals 6/5, and then they go back and they write it as 6/5 to infinity. Because they don't know really what they're doing. They're just trying to make the answer look like what I come up with in class. That will fail you. And it will fail you sometime around right now. Why? Because if you subtract 8 and you subtract 8, you get negative 4x is greater than or equal to negative 8. When you divide by negative 4, you divide by negative 4, you get x is less than or equal to 2. And because you had to rotate the inequality, this is going to become negative infinity to 2. And that's your answer. Okay.
So when I flip the sign around, it's also going to flip my notation around.
Right, because now x is less than 2 means any number less than 2. Well, what numbers are less than 2? Well, 1, 0, negative 1, negative 2. All those numbers are less than 2. How far left will it go? Well, it will go to negative infinity.
What if you had it flipped around? Like, what if you flipped it to negative 4x plus 8 is greater than or equal to 0?
Negative 4x plus 8?
Yeah.
You get the same thing.
Okay.
You subtract 8, you get negative 4x greater than or equal to negative 8. You're right back to where you were.
When you divide, that's when your sign flips.
So no. Let me answer the question.
Okay.
The question was, in part just because it's this on the microphone. The question was, why does the sign switch? And the answer is, if you divide by a negative number, this number is negative. That's what makes you switch it. Notice here, you divided by 5 and you didn't switch it then. Why? Because you divided by a positive number. Now, I know some of you are going like this. Yeah, but this answer up here is negative. That doesn't matter. It's only if you divide by a negative number that it switches. Okay? Only if you divide by a negative number will it switch. All right. So that was the question. Any other questions?